Hey everyone, thanks for tuning in again. In today's lab, we'll be going over a refresher to Anova. So specifically what we'll be looking at are two types of procedures for making mean comparisons. The first one is what I'll call DIY contrast or do-it-yourself contrast, and the second is Tukey's HSD or honest significant difference procedure. So for DIY contrast, we'll look at one complex and one pairwise. So complex comparisons are where you aggregate means across a combination of groups and compare that to another combination of groups or one group. So the main point there with complex comparisons is that we're aggregating groups or combining groups together and making comparisons between combinations. And then there are also pairwise comparisons, which are just between two groups at one time. So in this example, we'll be testing a single contrast at a time. So hypothetically, the scenario is that we've decided on a comparison we'd like to make before running an analysis. So this is also called a planned comparison. And in these situations, it's not really necessary to run the Omnibus Anova, but sometimes software will give it to you anyway. But it's just important to note that when you're running a planned comparison analysis, you do not need to run the Omnibus Anova, and you could just focus on the comparison that you're interested in. For more than one planned comparison, the process is a bit more complicated and there are more things to consider. So typically it's a common requirement that contrasts are orthogonal or independent, and that the maximum number of contrasts that you're allowed to test, and this is for maintaining a type 1 error rate of alpha equals 0.05, so the maximum number is equal to the number of groups minus 1. So for instance, if you have a factor with 3 levels or 3 groups, then you're allowed to test 2 contrasts, or you're allowed to make 2 mean comparisons. So the distinction between planned and post-hoc comparisons or contrasts can get lost because contrasts can be used either before or after. It's the choice of the researcher whether they want to do it before or after, but the distinction is still very important for controlling type 1 error. So having planned contrast is always recommended. The second thing we'll be looking at after DIY contrast is Tukey's HSD procedure. This is a post-hoc procedure, so we do it after running our Omnibus Anova, and if we find the Omnibus Anova f-test to be significant, then we can make all pairwise comparisons while maintaining alpha equals 0.05 using Tukey's HSD procedure. So the data that we'll be working with, I'll post it online. It's called anovadata.dat. For SPSS users, it'll be anovadata.sav. So we have a grouping variable, which is a categorical variable. It's called group, and there's 4 groups. There's the control group, the treatment group, treatment 1 group, treatment 2 group, and treatment 3 group. So there's 1 control group and 3 treatment groups, giving us 4 groups total. And then we have Y, which is a continuous outcome. So with that, let's go ahead and get into the lab. Alright, so I've opened up SPSS here, and what pops up by default, for me anyway, is this blank sort of a data spreadsheet. So what I want to do is open a data set, so I can go to File, Open, Data, and then I'll back up here just a little bit. So I store all of my data sets in the C drive, in the datasets folder, and our data set today will be anovadata.sav. So I'll go ahead and open that up. And so here I have the data set, and then I'll bring over also the output window. So I'll minimize that for now, and looking at the data set here, everything looks good. We have our 4 groups, so 1, 2, 3, 4, 25 in each group, giving us 100 total. And then we have our outcome here, which is Y. Alright, so now that we have our data read in, the first thing I want to do is compute the means by group. So I'll go to Analyze, Compare Means, I'll go to Means. I'll put group in the independent list because I want the means by group. and then y in the dependent list since that's our outcome. I'll click OK. And then here we have our means by group. So for the control group, which is group 1, we have a mean of about 24. For group 2, which is treatment 1, a mean of about 30. For group 3, which is treatment 2, a mean of about 28. And then our mean for group 4, which is treatment 3, is about 31. Okay, so now that we have that, we're going to go ahead and go into our first DIY contrast. So the contrast that we'll be testing first is a complex comparison, and I want to test whether the control group is significantly different from the combination of all treatment groups. So I'll go to Analyze, Compare Means. I'm going to go to Way Anova. And so this box will pop up. Y goes into my dependent list, and then my factor, which is the grouping variable, is group. And then we'll click on contrast to set our complex comparison. Okay. So here, all I have to do is specify the coefficients. So I'll specify them first, then I'll explain why the values are what they are. So first, it's -3, then 1, then 1, then 1. Okay. So the way you want to think about this is our first line here, first row, corresponds to the control group. The second row corresponds to treatment 1. The third row corresponds to treatment 2. And the fourth and final row corresponds to treatment 3. Now we want to compare our control group, which is up here, to the combination of all of our treatment groups, which is rows 2, 3, and 4. So the values of our contrasts, first the sign must be reflected between between the groups we want to make a comparison between. So -3 here, whereas all of the treatment groups are positive. Now, because I want to compare control to the combination of the remaining groups, these 3 remaining groups must add up to 3, which is what our control group is set to. So -3 versus positive 1, 2, the sum of 3 gives us the comparison between our control group and the combination of the treatment groups. I'll go ahead and click Continue, and then I can click OK. Alright, so this is our omnibus, but we don't care about that. All we care about is the contrast that we tested. So I would just focus on assumes equal variance here. We'll just assume that for the sake of this example. And if we assume equal variances, then our t is 5.16, and it is significant to the 0.05 level because it's less than 0.05. And so we can conclude that the control group is significantly different from the combination of all treatment groups. And that answers our first planned comparison. So let's say that instead I want to compare one group to one group. So one-to-one comparison. This would be a pairwise comparison. And so let's say that our planned comparison is I want to compare the control group to treatment 1. So we'll go back to our data set, and then I'll go ahead and go to Analyze again. Compare means, back to Way Anova. Everything is where it should be, so group is under factor, y is under the dependent list, and then I'll click on contrast again. Okay, so here I want to delete or remove this. I want to remove the previous contrast and specify a new one. So if I want to compare the control group to treatment 1, for the control group I'll specify -1, and then I'll switch the sign with the same value so I can make that one-to-one or pairwise comparison. And then I don't care about treatment 2 or treatment 3 right now, so I'll set those to 0. Okay, so again, first row, control group, second row, treatment 1, third row, treatment 2, fourth row, treatment 3. So I want to compare the first row to the second row, which is control to treatment 1, which is why these are the same value with the signs flipped. So the comparison is between these two here. That's why this is negative and this is positive. And since we're only comparing one group to another single group, it's 1 and 1, a 1-to-1 comparison. And then the remaining rows, since we are not interested in comparing those groups or including those groups in our comparison, are set to 0. I'll click continue and hit OK. Again, we don't care about the omnibus. All we care about is our planned comparison. And so assuming equal variances, our t is 4.59 or 60 with rounding. And again, it is significant to 0.05. So here we can conclude that the control group is significantly different from treatment 1. And that's that. So that answers our planned comparison and our research question. Okay, so now we'll move on to how to run Tukey's HSD procedure. Go back to the data here. All right, so I will go to, and here we do care about the omnibus because we don't want to follow up with a post hoc mean comparison if there are no significant differences between the means, which is indicated by the significance of our Omnibus Anova. So first, I'll go to Analyze, Compare Means, and then I'll go back to Way Anova. Again, this stays the same, so our dependent is y, our factor is group. But this time, I want to remove these contrasts. So I'll clear that out, and then instead I'll go to post hoc, which will open up this box here, and I want to run Tukey. I'll hit continue. So all we have to select is which test we want. So I want Tukey. I'll go ahead and hit continue, and then I can just go ahead and click OK. All right. So here's our Omnibus Anova, which is significant. Our F-test is 10.46 with rounding, and it's significant to the 0.05 level. So we can say that there are significant differences between our groups. So to check which groups are significantly different from one another, we run our Tukey HSD, which provides all of the pairwise comparisons between the groups. So there is a lot of redundancy in this table, but the way you would read it is compared to group 1, so compared to group 1, group 2 is significantly different because this is less than 0.05. Group 3 is significantly different, and group 4 is significantly different. And that is in comparison to group 1. In comparison to group 2, group 1 is significantly different, which we already saw. Group 3 is not significantly different. This is a new comparison. And group 4 is not significantly different from group 2, because this is greater than 0.5 here. And so a lot of these are redundant, but that's how you go through the table and make the comparisons. And to summarize, so 1 is our comparison, or 1 is our control group, and groups 2, 3, and 4 are the treatment groups. And so we can see here that all of the treatment groups, or each of the treatment groups, is significantly different from our control group. But as we go down through here, we can see that each of the treatment groups is not significantly different from one another. So 2 is not significantly different from 3, 2 is not significantly different from 4, and then the last comparison is 3 is not significantly different from 4. So again, to summarize our pairwise comparisons here, the control group is significantly different from each of the treatment groups, but the treatment groups are not significantly different from one another. All right. So again, we went through our DIY contrasts, and we first tested a complex comparison where we looked at one group compared to a combination of three groups. We also tested a pairwise comparison with our DIY contrast, looking at the control group versus treatment 1. And then we finished here with our Tukey, which first we ran the Omnibus Anova, and given that that was significant, indicating that there are significant differences between our means, we followed up with a post hoc Tukey HSD procedure to see which groups were significantly different from one another. And again, the Tukey gives us all of the pairwise comparisons while maintaining our type 1 error rate at alpha equals 0.05. And so with that, that concludes this lab, which was a Anova refresher in SPSS.